Okay, guys, today section 5.1, using fundamental identities. So, oh, now I got it mixed up. I think Jason passed out the gold sheets. You guys need stuff? Yeah, sorry. We passed it out as I was going to get you. So, Solana, you have, Kennedy, do you need both? All right, so guys, like I was starting to say, using fundamental identities. Jason passed out the gold sheet. Now, again, this is kind of a tongue-in-cheek, stupid joke, but this goes back a long time. This gold sheet of paper, again, at the top of the page, you can see that it's referred to as the buddy sheet. Okay, so again, like I said, long time ago, there was a teacher here named Mr. Coolis. He used to teach pre-calculus, and again, he had put this thing together, and he used to phrase it in the way that, oh yeah, you're going to use this sheet so much throughout chapter 5, it's going to be your best buddy. So he started calling it your buddy sheet. So I don't know, name stuck. I don't know why, but again, that's just sort of the idea. Essentially, we are going to know and use this stuff on this sheet. Now, again, I will say that you will not be expected to memorize everything on this sheet. We're also not even going to use quite every single thing on this sheet. The majority of it, yes. All right, especially these fundamental identities that you have the box around on the front page. That's where we're living today and tomorrow and in the majority of chapter 5. That's where we're at. And the good news is you look at it, it should look familiar. We saw most of these back in chapter 4 when trig identities were introduced. So if you recall back in chapter 4 when we introduced these things, we kind of, I don't know, I keep saying we, I don't know, I'm the only person here who's teaching you this stuff. So what I was trying to tell you and what we kept going through was with these fundamental identities was that, all right, we want to, make you aware of these. Especially, we want you to understand these reciprocals, these reciprocal pairs, and those reciprocal identities. That's going to be beneficial throughout chapter 4. Again, even some of the, like the quotient identities, the tangent equaling sine over cosine, and cotangent being cosine over sine. Again, we use those in chapter 4. But the way that I tried to phrase it was, okay, there's just, we want to get these out there. We want to get the information to you, but a lot more to come at a later time. Later time is starting today, all right? So, again, here in chapter 5, excuse me, especially the first part of chapter 5, we're going to be working with these a lot. The better we understand our identities, the easier things are going to be for us. Really, the rest of, if you keep on going on the calculus route, these identities and your understanding of these identities, it's going to make your lives a whole lot simpler, okay? Because that's what these identities are. Again, for lack of a better term, you may remember me talking about it this way when we introduced in chapter 4, but trig identities, they're simplifiers. You might have this big, nasty-looking equation, and we could use some identities to simplify it down to a more reasonable-looking thing. And that's exactly what we're going to do. It's just that the process that we're going to go through, at least initially, because every time we're at the level of mathematics where every time you do something new, it's going to seem hard, okay? Not everything, but the majority of things. The first time you see it, the initial time you see it, it's going to seem like, oh man, this is rough. And then you do a couple more examples and a couple more examples, and you quickly start to recognize patterns, and then you're like, oh, well, this actually isn't bad at all. I've got this, okay? And that's the hope. So please understand when we go into these problems that are requiring us to work with the identities, that there isn't a test at the end of the day today. There isn't a test tomorrow. Okay, the goal isn't to have this mastered because we talked about it for 20 minutes or 30 minutes. That isn't the goal. The goal is next week, prior to taking our quiz, we've got it down by then. And we will. We'll get there for sure. All right? So the goals that we have in mind here for section 5.1, first being that students be able to recognize and write the fundamental trig identities. Now, I believe wholeheartedly, as we're in these beginning stages, that recognition is going to be the first obstacle. We need to be able to recognize them before we can use them. Okay, so again, knowing what's on this gold buddy sheet is going to be imperative. Okay, the second goal that we have students be able to use fundamental trig identities to evaluate trig functions, simplify trig expressions, and rewrite trig expressions. A lot of words. They're essentially saying the same things. Is we're going to have big things that we want to simplify down to smaller things. For again, talk about an oversimplification of what we're trying to do, but that's really what it is. Okay, it's almost. I know that there have been some students in past years that have said that it's kind of like cracking a code or something like that. Yeah, sort of. I've always looked at the trig identities once we get into these problems. They're like puzzles. That's really what they are. And I know some people love puzzles, some people hate puzzles. Okay, but to me they're kind of like puzzles in that, okay, here we are and we've got to get down to here. We've got a lot of different ways that we could go. We're not certain. Maybe this will work, maybe that'll work, and we just essentially have to pick a target and go with it. And sometimes it leads to a dead end, and that's frustrating. I'm not going to lie to you. That is frustrating when you went this route, you did 3 steps, and you realize I went the wrong way. You got to retrace and go back. Again, we'll talk about all that stuff as we go, but we need to understand these identities first. Like I said, guys, this is essentially what you see on your buddy sheet, on the gold sheet. Again, there's a couple of things that are adjusted. Am I safe in assuming that when we look at these reciprocal identities, that we feel like we have those down pat right now? We used these a lot in Chapter 4, didn't we? We're not, it's not like we're coming into Chapter 5 and saying, all right, hey, forget everything you knew about reciprocal pairs. Cosecant's not going to go with sine and like that's not what we're doing. Okay, that's far from what's happening. We're consistently saying the same thing. We've already been using these identities, right? So again, we know that sine and cosecant are reciprocal pairs. Therefore, sine is equal to 1 over cosecant, or we could also say cosecant's equal to 1 over sine. We can do the exact same thing with cosine and secant, exact same thing with tangent and cotangent. So please, let's not make that harder than it needs to be. But there are technically 6 identities right there. We already know them. Okay? The other ones that we said that we hopefully have a really good feeling about. Again, this was introduced not this year, but last year in Algebra 2, that tangent's equal to sine over cosine. Okay? This is one that we used a lot throughout Chapter 4. Again, all that knowledge of the unit circle, without this quotient identity that tangent's equal to sine over cosine, we would not have been able to progress very far with our evaluations. Okay, we know that cotangent's the reciprocal of tangent, so hopefully it follows suit that if tangent sine over cosine, that cotangent's going to be cosine over sine. Again, both of these we've already used. Again, hopefully we're looking at this. I'm just looking at it as like a checklist, basically. Like, check, we have the reciprocals. Check, we have the quotient identities. And then we get to the Pythagorean identities, and I would say that we're probably not ready to check this one off the list yet. Okay, we've seen them. We showed you that these exist back in Chapter 4. We didn't do much with them. We did very, very little with the reciprocal, the Pythagorean identities. If there was anything that you wanted to essentially get memorized quickly, it's this guy right here, that sine squared plus cosine squared equals 1. I'm not trying to devalue the others. I'm not trying to say that the others are not important. Again, it's not what's coming out of my mouth right now. It just is that this one's going to be the one that shows up most often. This is the one, it seems like so many things are going to center on the fact that sine squared plus cosine squared is equal to 1. Okay? Now, we call these Pythagorean identities. Do you suppose it has something to do with Pythagorean theorem? It actually has everything to do with Pythagorean theorem. Okay, if you remember, again, on the unit circle specifically, cosine is the adjacent, sine is the opposite, but those are the 2 legs of the right triangle that we'd created. See what I'm talking about here? If we were to pick any point on the unit circle, that this is the cosine, this is the sine, I should have made this a lot bigger, and the fact that it's a unit circle, that's going to make the hypotenuse or the radius 1. So at that stage, is it making more sense just using the Pythagorean theorem that leg squared plus leg squared equals hypotenuse squared, or sine squared plus cosine squared equals 1? Okay? Now we're going to have variations off of this, meaning, yes, sine squared plus cosine squared equals 1, but could I get sine squared all by itself? Like, could I subtract the cosine squared over? Call it sine squared equals 1 minus cosine squared? Or could I get cosine squared by itself? Subtract the sine squared over? And we could do that for all of these other ones as well. Okay? Now again, we'll have more notes on that in the future, but again, that's just kind of where we are. So I would say that generally, students come in, and again, like I told you a few minutes back when we were going through our test, I think this is my 8th year teaching pre-calculus. So again, I've got 7 years worth of experience going back here in terms of where students lie with these identities. Generally, people come in, and after seeing the reciprocal identities and the quotient identities, okay, feel good about those, and eventually we get to the point, and eventually might not be now, but by like, I don't know, this time tomorrow, hopefully we're starting to feel pretty confident with these Pythagorean identities in terms of being able to recognize them. Some cases, yeah, we might have to try to study a little bit, we might have to try to memorize a little bit, but once we get there, these are the ones that when we get into a problem and we're trying to use them, it seems like even if you haven't memorized, a lot of that just kind of floats away. All right, so I would just tell you, looking at these three, we have sine squared plus cosine squared equals 1. We have 1 plus tangent squared equals secant squared. We have 1 plus cotangent squared equals cosecant squared. That pretty well covers all 6 of the trig identities, or the trig functions, excuse me. Okay, so if you're working on a problem and you see that you have some trig function squared, there's a really good opportunity to use one of these. Can't say it's 100%. Can't say that every single time you see cosine squared that you're going to turn it into one. I'm not saying that, but it's a decent option, I suppose. Okay? All right, so next up, the cofunction identities. Believe it or not, we've already talked about these. We just use different terminology and things like that. But again, the cofunction identities. First and foremost, they look harder than what they really are. Okay? They look way more difficult than what they really are. Here's what we're saying, is that if we have a right triangle, and we're claiming that the sine of pi over 2 minus u is equal to the cosine of u. All right, so that means that we have an angle that we're marking as u. So that's u right there. There it is. Immediately, do we know that that other angle is going to be 90 minus u? Do we know that because this is a right triangle? We know that the 3 angles have to add up to 180. That rule hasn't changed since elementary school. Okay? So if this is 90 degrees, we know that the other 2, the acute angles, must also sum to 90 degrees. Okay? So the only real change that we have is that we're not saying 90 degrees, we're calling it pi over 2. So are we good with claiming that the other angle is pi over 2 minus u? Are we good with that? And as long as we start to recognize that that's all that we're saying, is we're saying that if the first acute angle is u, the other one's going to be pi over 2 minus u. Then it starts to make a whole lot more sense. But all that we're saying is the sine of the other angle is equal to the cosine of the current angle. Okay? I like the picture better. If I were to look at this piece here, let's call it A, B, and C. If I wanted to find the cosine of angle u, what would that be? It's cosine of angle u the way I drew this up. B over C, right? Cosine would be B over C. Let's switch things up. Let's go to the other angle, calling it pi over 2 minus u. What's the sine of that one? B over C. So what we're claiming is that that connection is going to happen. Not only is that going to happen with sine and cosine, or backwards cosine and sine, that's also going to happen with tangent cotangent. It's also going to happen with secant cosecant. Okay? Now I'm pretty certain, again, over time I've gotten, I don't know, I feel like the ability to where I can kind of, feel the vibe in the room somewhat, and I can tell some of you are like, yeah, known that for a long time. All that we're doing really is changing up the notation. Okay, others were like, hold on, let me write this down. Okay, but again, all that we're saying is that within one triangle, that the cosine of one angle is equal to the sine of the other angle. All right. Even and odd, we're going to talk a little bit more about this as we go today, but even and odd identities. If you recall, back in chapter 4, we already talked about even and odd, but what we have going here is that the sine of negative u, that's equal to negative sine u. Okay, the reason, sine is an odd function. It's not even, it's odd. Because if I plug in an opposite value, I'm going to get the opposite outcome. So sine, cosecant, tangent, cotangent, they're all odd. The only even ones are cosine and secant. And again, I've got another slide in here that we're going to talk about that a little bit further. All right, so let me stop this video here.